what would be the name of this molecule? Obviously, the cyclohexane is the biggest part, so we're going to take the name of cyclohexane as the main chain. It has two substituents, one here, methyl groups, the other there, ethyl groups. So as for the numbering the carbons of the cyclohexane, we can do this way or we can do the other way. Should we do 1, 2, 3 or 1, 2, 3? In either way, it's be 1 and 3 or 1 and 3. So that's kind of tied up. So when you have a situation that tied up, then you break the tie using the next rule, right? Well, this rule number 2 get tied up. Rule number 3, name the substituents. Doesn't really do anything. But rule number 4, we're going to put them in alphabetical order, right? So the one with the alphabetical comes first gets the lower number here. So rule number 4, break the tie of the rule number 2. So that's the reason this carbon gets number 1, because of these carbon have ethyl groups as a substituents. Number 3 carbons has a methyl groups as substituents. And you know ethyl starts with E, methyl starts with an N. Ethyl comes first, then methyl. So that's why this carbon gets number 1. So 1 ethyl, 3 methyl, cyclohexane. That's the name of this molecule. So I teach this in the class. At the time of the test, I ask this molecule. Then it looks same, right? If you didn't pay close attention, then you're going to find out this and that almost looks identical. You got the cyclohexane there, you got the methyl substituents, and you got the ethyl substituents. So some of you most likely choose the same numbering system because if you somehow remember that, yeah, in that situation, ethyl is the one that comes first in alphabetical order, so we should make this one number 1. Will that work here? One thing that you should pay attention to, there are 2 methyl substituents. Why they should change the numbering? Because if you do this way, that's going to be 1, 3, 3, right? So that's the higher numbers compared to 1, 1, 3. So most likely the disubstituted carbon will get the first choices, right? If there are more than one disubstituted carbon there, then of course, what's the name of the substituents could matter too. But if you got a disubstituted carbon, monosubstituted carbon, then the more substituted carbons are better than number 1. Because of rule number 2, our objective is to make the number grow as low as possible. So if you're using this same numbering system you see there, that's going to be still the 1 ethyl. Ethyl comes first. 3, 3 dimethyl cyclohexane. But you notice that if you're using the red one, the carbon bearing the 2 methyl group at number 1 is going to be 1, 1 dimethyl instead of 3, 3 dimethyl. So which one is better? Which one is actually the top one? The lowest number 1. So you could be easily confused by the question that you solve at home, because it's not, it may not even same question, because you can see that just having another substituents will change the number, and you may get the wrong answer. So you really have to follow the rule, not memorizing it or just patronizing it. Okay.
Like
methyl? Both methyl? That would be, then in this case, then it really doesn't matter, because when the molecule becomes symmetrical, then there's an ambiguity applies. But in the end, you get the same result. Okay, I hope that you get the points I'm trying to make here. Sometimes in a question, the question you see the text may look similar to what you saw before, but unless it's the identical one, it may be different. And not the name of substituents, but the numbering can be. Because a certain cyclic molecule is a little bit hard to choose which one gets number 1 and then the other, because there's other possibilities. But that's something that I want you to pay attention to using this. All right, so all together, let's try to find a name for these two molecules there. What is the name of that molecule? Then question comes, which one we gonna take as a main chain? Are we gonna take the cyclobutane as a main chain? Then are we gonna take this part as a main chain? The more number of carbon should be given to the main chain. This one, this long, the open chain one, 1, 2, 3, 4, 5, 6, 7, 8 carbons there. And that cyclobutanes are just made the 4 carbon. So I'm pretty sure that you will easily choose the octane as a main chain. And then when octane becomes a main chain, that part just becomes a substituent. In cyclobutane is substituents, cyclobutyl. But you need to place a number. So what is the number you should give for this position? 1, 2, 3, 4, 5. 5 cyclobutyl octane or cyclobutyl octane. Because an open chain one, you don't start numbering from the middle of the chain. You start from either end. So this is a 1 or that's 1. Counting 1 from this end, it will give a smaller number possible. So that's the reason it gets a 4 cyclobutyl octane. The next one, that's the 3 carbons here. These are not carbons, right? And this is 6 carbons here. So we're going to choose cyclohexane as a main chain. And then all of these are substituents. And the name of these groups of substituents, what is it? Is it isobutyl? It's just 3 carbons per chain. So it's propyl, right? Either propyl or the isopropyl. And then when you say propyl, that typically means the long chain one, right? With the linear format. And these ones are isopropyl. And that's a nitro. And then the Br. What should be the name of the Br as a substituent? Bromine. Bromo, right? It ends with an O. And then another nitro group there. So 2 nitro. So we should call it dinitro, right? Not nitro. The question is, I mean, those are the easy part. The question is, what are we going to make the number 1 carbon? There are too many substituents. I mean, we wouldn't start either from here or there. That would be too silly. Either from this one, that one, that one, that one, right? You have 4 possible choices, number 1. Which one would you choose? If you choose that one, it's going to be 1, 3, 4, 5, right? It will not be a choice. If you choose that one and go this direction, 1, 3, 4, 5, same way. So that's what 2 possibilities, right? I just mentioned. But another choices can be starting from this one, and then number 2, number 3, and number 5. I think this is a probably way to make the number as small as possible. So that's the case that you got 1, 2, 3 carbon gets number all the substituents, and then 5 get another substituents there. So 1 and 3, 2 nitro groups. So 1 and 3 dinitro is a 1 carbon substituent. 2 bromo, and then 5 isopropyl. So each one starts alphabetically first. Is a bromo. So 2 bromo, then 5 isopropyl. Isopropyl, as I said earlier, doesn't start with a P, right? It starts with an I. Iso and cyclo, those prefix, you should count it when you do the alphabet ordering. So isopropyl start with an I, not P. Same thing go for the isobutyl. Isobutyl start with an I too. And then dinitro. Dinitro doesn't start with a D because di is a prefix we use to refer how many repetitions we see, right? So dinitro start with an N. So 2 bromo, 5 isopropyl, 1, 3 dinitro cyclohexane. But you may have a question there. What if we number in other directions? Is that your question? I measurement. So you can start from here and then go this way. There's still going to be 1, 2, 3, and 5 substitution patterns. And then if you name this way, you're going to find the name becomes the same because of 1, 3 dinitro still there, 2 bromo still there, 5 isopropyl still there. But how come 2 different numbering in the same name? It's because of molecular symmetrical. You can see that there's a symmetrical plane right here. So in this example, 1, 3 or 1, 3 makes the same. So there's another thing, something that you should pay attention throughout the semester. The symmetry of the molecule sometimes could matter. All right, so I hope that, I know this question you're going to go through a lot, but if you follow the, procedures, then you get to learn. I mean, nitro is an NO2. Are you trying something else?
Yeah.
If it's a lone pair there, you're probably thinking about NH2, right?
Yeah.
When it's an NH2, it's an amino, right? It's a different function. It gets a different name. Yeah. Nitro doesn't have a lone pair. If you draw the Lewis structures, its nitrogens are positively charged. It doesn't have a lone pair there. So I think you're confused between amino and nitro. Depending on what the other functional groups are, typically works that way, right? Many things works that way. All right. Well, I hope that these are kind of reasonable things, right? I know it's kind of the steps you have to follow, but at least you follow a step, then you come to your name. Some things are steps longer, some of the questions, and things like that. Well, as I said, you can name the molecule. That also means that you can draw the molecules based on the name. But drawing is simpler because they need to pay attention that what you draw, how you find out what is what. All of these things substituents, and that part is the main chain, like cyclohexane. So I guess we basically start drawing the cyclohexane first. It's a circular form, so we really doesn't need to start number 1 here. Any carbon gets number 1, right? It's totally up to you. I just choose that one number 1 for the arbitrary choices. But you can choose any carbon number 1 because cyclic forms. Only thing that matters is number 1 carbon has 2 methyl groups, dimethyl. So we should put dimethyl there, 2 methyl there. And then number 3 carbon having an ethyl group there. This molecule can be drawn maybe in rotated form in other way. That's fine. They're all the same molecule, just drawn differently. So they're all okay. These are cyclohexane again. Cyclohexane there. You got the 1, 2 dichloro. So 1 and 2. Not the 2 chlorine the same carbon. You should put the 2 chlorine of 1 in carbon number 1, 1 in carbon number 2. And then 4 nitro, then of course you gotta know what is a nitro, right? Nitro is an NO2. If it's an NH2, that's an amino.